welcome you to the 50th lecture of Surface Mining Technology NPTEL online certification course. This is the second lecture of inland transportation system, and in this lecture we will mainly emphasize in the inland water transportation system attempt in the currently in the Indian subcontinent, especially in the country, and we will also emphasize on the slurry pipeline transportation system as is currently being practiced or attempt are being made in the country. Beforehand we have seen what are the other possible transportation system available or popularly used in different places. So, as we do, let us have the glimpse of the learning background for the surface mining technology course, and these are the learning objectives set for the surface mining technology course, and these are the expected learning outcomes from the participants of surface mining technology course. These are few more expected outcomes. These are some of the textbooks and references. However, these inland transportation systems are basically these lectures are made from the website data, website resources. Some of the portions has been taken from the lectures of Professor Ramani also. These are basically considered in these lectures, and there are good web sources are available for these lectures. Before as we do, let us look into the retrospect of the previous lectures. In previous lecture, we have completed the phases of mining a deposit. We have also seen the commencement of mining excavation, surface mining excavation through the opening of box cut. The different unit operations, drilling technology, blasting technology are discussed. After that, we have discussed the excavation of rock mass by the ripper, that is the blast free technology. After that, we have covered the excavation of the fragmented rock mass by the excavator and simultaneous loading of the same to the dumpers, that is the transporting system, and we have gone through the shovel dumper combinations also. After that, we have covered the excavation by surface miner and followed by excavation by drag line, excavation by bucket wheel excavator, then the high wall mining operations and the haul road construction maintenance, these are covered. And now currently we are looking into the inland transportation system. The previous lecture is already covered, which is basically introduce you to the different types of inland transportation system in general practiced for in different countries. So, the objective of this inland transportation system is to understand the various X-speed transportation system, to learn the key component to choose the transportation systems, and to learn the inland transportation system in India. So, we will emphasize the inland transportation system in India in this lecture. As we have seen, the most general mining phase 2 storage transportation system is conveyor belt or dump trucks. These are the most popular system, and from this crushing plant or storage to the customer is mostly either by the trucks transport if it is small and nearby, and if it is large scale requirement and away, then it is railway transport. And currently for some particular segment we are using small ships and barges. This is recently introduced system. Otherwise, in India we did not have this concept, but obviously in USA etc. this was popular since long, and this pipeline and belt conveyor transportation systems are also followed, where the dedicated customer is there. That means, these systems are not applicable for the flexible customers. So, if these customers are known and there is no change in their demand. So, dedicated customer with fixed demand, in that case only these things are used, and same is for ropeway also, a real ropeway also, or cableway, ropeway or cableway. So, these transportation systems are followed, where in general the captive mining is carried out. That means, the production point is fixed, the destination point is fixed, and the demand is also fixed in those cases, because there is no change in the capacity of this system, belt conveyor system capacity, slurry pipeline system capacity, ropeway system capacity. As there is no changes in this, in those cases these systems are utilized, but these are having the flexible demand system, where this can be used very easily, and our customers are not also not fixed. So, in those cases these systems are basically utilized. However, the adaptation of these are also depending on the country's rules, cost and availability. This is particularly important for this region. This is very flexible system. Whenever anyone is willing to have this one, they can have a truck transportation system. There is no compromise on this, but whenever it is a question of railway transportation system or ship transportation system, then the problem arises with the number of available rail or ship, because these are not sufficiently available, or the sufficient routes are not available. That means, if someone is willing to have a railway rake for transporting coal from a particular point to a particular point, say consider that you are transporting the coal from the BCCL to you are transporting that to some point of the Gujarat, then it may be possible, if they are willing, then also that rail rake is not available to take that material from that particular point to that particular point. So, these systems are very problematic, and that is why it is not always possible to have this one. Similarly, this ship, that means this connectivity between this BCCL to the Gujarat, this ship connectivity is not there. So, these things are very important, that the availability of the system and its allocation system, country's rule. Especially countries like India, we are having a rule that the railway rakes are being booked depending on the distances, and that is why always the dedicated rakes may not be available for the particular transportation of that one. And that basically forcing the companies to go for truck transportation system, even for a long distance transportation system, maybe from BCCL to Gujarat. So, that is a more than 1000 or 1500 kilometer distance is being travelled by the trucks because of the dearth of railway rakes in those cases. So, that may be the possibilities, and that is why this is very important. Sometimes rakes are available, but the tracks are heavily loaded. If once it is loaded, that is taking long time to reach to the destination. So, these are the problems, and those problems are very important and should be addressed or should be considered while the decision of the inland transportation system is made. Now, this is one very important video, that is the country's attempt to adopt the inland water transportation system is basically shown in this figure. This is the National Waterway 1, termed as National Waterway 1. And this National Waterway 1 is basically the water connections through the river Ganga. 1620 kilometer long waterway is constructed from the Prayagraj to Haldia port. So, it is from Allahabad, you can say Allahabad, almost close to Allahabad to the Haldia port, and this is the port which is constructed in the Haldia. Haldia is adjacent to the Bay of Bengal, and that port is basically constructed to transfer the material through the ships or barges through the river Ganga, and this is the views of those ships as those are moving. This is through the river Ganga. The proper depth of the river is very important. Controlling the depth of the river is very important. In fact, the water sufficient water supply in the canal must be placed, so that the depth the water height can be maintained and the ship can move through those cases. In fact, the tide effect initially is the advantage for the ship, but at the upper side of the river Ganga the tidal effect is not that much significant. So, sufficient water supply has to be controlled in that particular case. In fact, with this development of this one, it is having facilities that the Singrauli coals are suitably transferred through this channel, as well as the coal which are basically received in the Haldia port, Indonesian coals and Australian coals are also able to be shifted transferred through this inland water system to the up to the Varanasi. So, that is the benefit of this water system, inland water transport system. This is another video. This is for the same, on the inauguration of the same, and this is showing that the transportation cost 2.28 rupees, the transportation ton per kilometer is the truck transportation cost, 1.41 rupees is the ton kilometer transportation cost, whereas close to 1 rupees is the cost of transportation cost for water transportation system. And whereas this can be seen for a truck which can take in and around 24 ton, the rail is single rake is carrying around 85 ton and 105 ton can be carried by the waterway because of the buoyancy, the actual load which is taken out by the ship or propelled by the ship is not that much significant. A little bit problem is there if in consideration of the transportation system, loading and the unloading systems. Generally in the case of truck, a dumper can be loaded by the excavators and can be moved taken out by the dumper itself. Rail can be similarly the dumping system can be made for the railways also, but tippling system, system can be made for the wagons. However, for the water transportation system, the grab etcetera, which are utilized for the loading and unloading, is not that much efficient system. That is a little bit problem with the loading and transportation system in this case, but that problem may be overcome because of the cheapest transportation system of this cheapest transportation system for this inland water system here. So, now in the Inland National Waterways Act 2016 has been made, and around 20,000 kilometer waterways are to be developed, and for that attempts are being made in the country. This will change significantly the waterways. These are the proposed waterway which is already completed. This is almost in the finishing stage, and these are some of the others waterways which are proposed and can be developed in the future as per the proposal. These are the identified. So, these are the identified, these are declared, these are under construction, and these are the international route is under construction again. Now, let us look into the technical details, where 1 horsepower load can take 150 kgs on road, 500 kgs on rail. It takes 4000 kgs on water because of the benefit of the buoyancy, and 1 liter fuel 24 ton kilometer on road, 85 on rail, and 105 on water transportation system. And cost of developing waterways are much lower than the rail and road, because you do not have any cost for the construction, only the ports and loading unloading system has to be developed. Ports and loading unloading system has are required to be developed, otherwise there is no construction cost on the road. And another important part is that the availability of the water is very important. Availability of the water is important, and depending on that, your size of your ship is also basically depending on the availability of the water. If we are considering the emission of the greenhouse gases, this is almost for the water transportation system 50% of the truck. So, that is why this is also very efficient one. Rail in India mostly travels on electricity. However, electricity is basically coming out from the thermal power plants. Most of the Indian power source, almost 60%, more than 60% is from the thermal power plant. So, that is why this is these two are generating more carbon dioxide, and that is why, but in the inland waterway transportation system only 50% CO2 are coming, though these are mostly diesel operated, or you can say oil is used, diesel oil is used for the as the motive power for the running of the engines. And traffic congestions, all these are not that much, and most significant part is that the question of road accident is almost 0. So, when the inland water transportation system is there, unless and until that ship crews are facing any problems, the accident is almost 0 in the case of inland water transportation system, but if it is a road traffic, then there is significant accidents, and often in rails also occasionally we found because of the problems in the tracks etc., because huge human interference are there. So, that is why the problems are associated, accidents are associated with the rails and roads. These are creating the problem hindrance in the normal transportation of the people. So, these are creating problems, but the inland water transportation system does not have this type of difficulties. So, that is why inland water supply water transportation system is very important and popular one. Most of the coal fields are located in the eastern India. Thermal power plants are located in the all over the country. So, there is a huge mismatch in these. Coal sources are eastern side, thermal power plants are in the other places, because the power loss is unwanted, transmission loss. So, coals are required to be transferred a long distance, and another problem is that Indian coals are having very high ash percentage. So, that is why calorific values are reduced. So, whenever a coal is being transported, a significant energy loss is there, because that is containing high ash. So, the containing that unwanted material has to be travelled a lot, and that is why the energy utilization is not that much significant. So, transportation of this coal up to a long distance is very problematic. Shortfall of in wagon availability is 120% in this case, and that is why Eastern Rail, Southeastern Rail and East Coast Railway having huge problem for allocating the rakes for the Coal India Limited. So, that is a significant problem, and that is why inland water transportation system may solve some problems in this. So, this is currently the available inland network, which is allowing the NTPC plant at Farakka, and this can be seen that the linked mine ECL Rajmahal is facing coal shortage due to the inadequate coal availability in this mine, and that is why the Farakka located at this facing the problems of the availability of the coal, which can be solved through this. The Indonesian coal can be taken and then transported to this easily, and can has the benefit of this of inland water, inland waterways can be utilized for this transportation system. And Andal Saitya single line section, railway could not supply more than 7 rakes per day from other source, including the imported coal from the Indonesia. So, that is why this ship transportation system Sagar Island can be taken to Farakka through inland water supply system at a competitive with present payments. So, because of this transportation requirement, a separate dock is created in the Haldia port, and that is why that is becoming popular transportation system nowadays, in which the coal is being transferred. Similarly, for Mahanadi also, the Talcher coal is transferred to the Paradip port. Then from Paradip port, the inland water supply is waterway is used to transfer the coal to the Farakka. So, that is also another very important one, route of transfer of coal from Mahanadi coal field to the Farakka thermal power plant. National Waterway 5 has been notified by government in 2008, which is having Talcher to Dhamra 265 kilometer stretch, then Mangalagari to Paradip 101 kilometer, and this is basically designed in this way. These are yet to come out, these are in the proposed stage, and there are many proposed networks are there, which will gradually come in later one. Next part is the slurry pipeline transportation system. The slurry pipeline is a special case the SR is doing on this. This is a hydraulic transportation system in which the ore concentrate and water is mixed to make a slurry, which is pumped through the pipeline and that is transferred to a long distance, and time to time the head is being maintained, so that the transportation of the same can be continuously carried out without any hindrance. This is the video of this slurry transportation system. So, this is the pipeline, how the pipelines are laid. In general, most of the cases the pipelines are made underground. So, this is the underground trench is made, then the pipeline is laid, then again it is filled back. So, 235 kilometer this is made through this terrain. And this is the how the slurry is prepared. This is the way the slurry is prepared, then the pipeline is utilized to pump them. So, this is the pipeline is utilized to pump them up to a long distance. So, this is the pipeline laid, and at the receiving end of the pipeline the dewatering is carried out and the material is again reused there. So, this is the laying of the pipes, and this is the dewatering system. In India earlier, from Kudramukh we had a slurry pipeline system, but after the Kudramukh mine was closed, then there was nothing. After that, currently SR has set up. Apart from that, there are few notable slurry pipeline systems are there. 396 kilometer, 522 kilometer, 439 kilometer, 112 kilometer. So, these are the very big slurry pipeline systems were available throughout the world. This is Indian scenario. We had one from Kudramukh to Mangalore port 68 kilometer, which gradually stopped after that. Currently, Kirandul to Visakhapatnam SR Steel has set with 267 kilometer, and another one in Orissa to 30 kilometer, and these are also another project of the SR Steel. So, these are few notable slurry pipeline system of the country. These are few more proposed one. and these are the pictorial view of the same. Major system which is required in slurry pipeline is storage tank, agitator, then the discharge receiving terminal, slurry pipeline, pumping stations, valve and choke stations, and after that in the receiving station the dewatering system. So, this is more or less all about the inland transportation system, either it is a water transportation system or conveyor system or pipeline system or truck or railway transportation system or maybe the cable ropeway. Details of that is tried to provided in these two lectures. So, let us stop here. Thank you.